Good evening, everyone. My name is K. Shivashankar. I am from the department of the ECE. Today I am telling about the probability theory and stochastic process seminar. My seminar topic is ergodic process and the ergodic theorem. First, we will discuss about the introduction of the stochastic process. System that involves randomly over time where future stages depend on the current conditions, probabilistic rules. This is called about the stochastic process. And the stochastic process are have two: random evolution, time dependent, probabilistic nature. First, we will discuss about the random evolution. Future behavior influenced by the change is called random evolution, and we will discuss about the time dependent. Change occurs continually in the discrete. The time frequency from the continuously discretely change is called time dependent. And next, we will discuss about the probabilistic nature. Governed by the probability distributions is called probabilistic nature. Next one. Next, we will discuss about the define ergodicity core concept. What is ergodicity? A process of ergodic when it is the time average equals to the ensemble of the average observing path long enough in the revivals of the system wide behavior is called the ergodic core concept. In the ergodic time core concept, there have the two types. There is time average, ensemble average. Time average, single trajectory observed from the infinite durations is called time average, and the ensemble average, all possible trajectories is of the moment is called ensemble average. And next, key insight. In ergodic system, one representative trajectory contains the all statistical information in the entire system. This is about the ergodicity in the concept of the in the core concept, time average, ensemble average. In the ergodic system, we have the representative trajectory and contains the all statistical information in the entire system. Next, ergodic process in the real world examples. In our daily life, there are ergodic process, different types of processes are there. Example, coffee mixing, temperature fluctuations, car shifting, and the other types of examples in the ergodic process in the real times examples. First, we will talk coffee fixing. They despite uniformly long observations, revivals complete the distribution of the pattern in the coffee mixing and the temperature fluctuations. Practical terminal motion, average kinetic energy matches system in the temperatures in temperature fluctuations and the card shuffling. Cards shuffling in types of playing cards or cards, that types of cards in shuffling. The repeated shuffling evenly samples are the possible of the arrangement in the ergodic process in our daily life. Next, the ergodic theorem. This is the mathematical representation of the foundation for an ergodic process. Time average in measurement converts to the expected value in the three types of first one sample path, time average, and the convergence. This is about the ergodic theorem in the mathematical foundation for an ergodic average time value, measurement of the convergence expected value. First one, sample path. Observe single trajectory over the time in the sample path. Time average. Calculate the mean of the along the path and the convergence. Approaches the true expectations in the convergence. The formula of the ergodic theorem in the mathematically represented has limit extend to infinity 1 by t integral 0 to t f of xt into dt equal to e of fx of x. It is in terms of the mathematical conditions in the ergodic process. Next one. Applications on implementations of the ergodic theorem and ergodic process. First one, statically mechanics. Second one, signal processing, climate modeling, financial analysis. First, we will discuss about the statical mechanics. What is statical mechanics? Justifies use observable averages to the present the properties. The one who present the averages in the present of the system and they give properties and the average values is called the statical mechanics and signal process. In a signal, we have a single analysis sufficient from the frequency spectrum. In the estimation, we have a sine wave that we signal when the wave formation in the frequency in the spectrum estimation and the climate modeling. Long historical records, revival of the climate statically reliability and the financial analysis. Past price patterns inform expected futures of the market behavior in terms of the mathematical conditions in the ergodic theorem and ergodic process. Next one, joint ergodic process. Multiply the process who combined behavior exhibits ergodic properties together that the revival of the complete statical information in the joint ergodical process in the individual ergodicity and the joint ergodicity. In the individual ergodicity, we have the each process ergodic along time averages matches assemble in the means and the joint ergodicity paired process together from the sample full joint distribution. Joint in the ergodic process. Multiply the process that combined behavior exhibits to the properties together their revival. Complete the statistical information of the individual ergodic process from the information of the statistical information in the match that the ergodically sample distribution in the ergodical distribution. Next one. Significance of the jointly ergodic process. This is the representation of the joint ergodic process. There are three: correlation destination, multivariate sampling, system prediction. In the correlation detection, identify the relationship between dependent of the phenomena and the multivariate sampling. Single observation path captures full multivariate statistics. In the system prediction, joint behavior determines coupled system of the evaluation. Example. The daily life examples of the significance of the joint ergodic process is stock price and the trading volume. When we the stock prices in the shops, the trading value, the percentage will be increases. Joint ergodic means observing the one pair revivals, correlation between both the variables. This is about the significance of joint ergodic process in the correlation detection, multi-rate sampling, system prediction, joint behavior of the derivative couples of the evolution. The stock prices in the trading of the value is the example of the significant jointability of the ergodic process. And next one. This is the pie diagram of the real world applications in the ergodic process and ergodic theorem. In the pie represents the diagrams of the neuroscience, energy system, climate science, financial market, and the molecular dynamics. There are five types of real world applications. First, we will discuss about neuroscience. Neural firing is the pattern of the single neuron tracing and the revival of the population of the people in the neuroscience of the pattern in a single revival pollution of the statistics. This is about the neural science in the real world of the application. And let's we discuss about the molecular dynamics. The protein folding of the molecular trajectories, revival of the thermodynamics properties, trajectories, molecular theory, and the revival of the molecular dynamics in the real world of the application. And the energy system. Energy system means wind, solar, air, variabilities, temporarily pattern, predict of the resource availability and pressure, temperature, wind, solar, variability in the temporarily of energy system in the pattern, predict that the availability of resource from the real world application. And next we will discuss about the climate science. Temperature prediction, temperature specification is the coupling of the historical data revivals from the pattern of the climate science and the financial markets. A set of the correlations of the financial markets containing plot theory involving the market sharing and the market pricing of the financial markets. This is about the real world applications of the process in the neuroscience, molecular dynamics, energy systems, climate science, financial markets. These are the five types real world applications of the ergodic process, ergodic theorem. And next, conclusion. The conclusion is key takeaways. The conclusion is one path full pictures, time meets assemble, joint insights. Ergodic system needs only single trajectory for the complex statistics in the one path of the full picture. That is about the conclusion of the one path in the full picture. And the time meets assemble of the time average, time assemble time becomes equivalent of the assemble meets that the time. In the time average, time becomes equivalent. And the joint insights, multiple process together revival completely interdepends on the Ergodic theorem and ergodic process of the observation, making the infinite observable thought fight in the finite of the bridges in the ergodic process and ergodic theorem. This is about the ergodic theorem and ergodic process.